Hello, welcome to Lesson 2, Systems Thinking. We're about to introduce a powerful concept that will allow you to solve wicked complex problems no matter what range, no matter what type, and we'll leverage a technique referred to as systems thinking. So let's take a quick look at where we were, where we are, and where we're going. Lesson 1, we focused on introducing you to the concept of the system decision process, the SDP, which is what we will refer to it throughout the course. And now we move into introducing you to the systems thinking block, overarching idea of systems thinking. In the next class, we'll unpack systems thinking even further and expose you to the idea of distinctions, systems, relationships, and perspective, or the framework referred to as DSRP, which will be introduced through the text by Dr. Derek and Laura Cabrera. So here's our agenda for the day. We'll engage in just understanding what we had to do last class, take a look at some homework, talk through some systems thinking, highlight the idea of systems dynamics, give you an approach to think about the system thinking characteristics and habits, and then do a desk problem while you're in the synchronous portion of the class and unpack the GM OnStar case application. So you may wonder, what is systems thinking? Well, systems thinking is a holistic framework and worldview that recognizes a system as an entity first, as a whole, and it fits in relationship with its environment being primary concerns. And this is what Parnell, Driscoll, and Henderson highlighted on page 30 in the Green Book. But if we think about the skills necessary, if we look towards the future, if it's 2020 now, the World Economic Forum focuses on what skills are necessary for us to operate effectively in the future. And if you look at the red boxes, you'll see analytical thinking and innovation, technological design and programming, critical thinking, complex problem solving, systems analysis and evaluation. These are all things that are foundationally around the idea of systems thinking, looking at a holistic idea, being able to break those ideas into parts, being able to move forward to solve complex problems. So what are those elements? So we think about a system that we just refer to as an overarching idea or a system. So systems can be open or they can be closed. There's a lot of inputs that could feed into a system where you may get some feedback or not. In a closed system, the environment may play on that closed system. And if we think about any kind of systems thinking provides that structure necessary to move a process along. But it's also, with structure, there are boundaries. And so as we look to the right, you see classification, spatial arrangement, visibility, and evolution, and we'll discuss those later during this discussion. And then with any structure, there could be some mathematics behind it in order to better understand, is this the right structure? Because not every structure we leverage is appropriate, and so you need to do an appropriate analysis to ensure that you're moving in the right direction. So let's talk about structure. A structure of a system can be analyzed in terms of its relationship with the environment. And as described previously, open versus closed. So, and if you want to think about a closed system, one way to think about it is the defense enterprise and how we have historically built major systems. So we think about building an Abrams tank. Well, that's a pretty closed system. It is not open to new innovations. It is built by a certain manufacturer. It is connected to very specific technology that is closed, mainly for security. And if we think about an open system, we can think about new aviation that's being built, new rockets, new planes, new unmanned aerial devices that may be open. And what that openness provides the opportunity for that particular system to evolve as necessary based on the environment. But then we must classify our systems, and we have three ways in which to do that. They can either be physical, abstract, or unperceivable. Again, going to the tank model or Bradley is a physical classification. It's a thing, exists in reality, time, and space. Something more abstract is just more of an idea. And so think about an artificial intelligence kind of systems, for example, when some of our Jeopardy players were able to beat an AI system, or unperceivable, completely outside of the boundaries of our thought, is sometimes a classification for a system. A physical system has subclasses. So there's things that are living, not living, man-made, or natural. A non-living has no genetic connection to the system. Living, a beehive. Man-made, Hoover Dam. Something natural, well, just think about the Hudson River as a physical system. So the Hudson River, as we think about it at West Point, is a boundary between one side of the river and the other side of the river, but commerce can move up and down in order to facilitate commerce in an ecosystem. So let's think about classifying the following system. Think about quantum physics. Well, that's actually more abstract. An autonomous vehicle is physical, non-living, and man-made. But the U.S. economy, some may think is a very solid thing, is very unperceivable because there's a lot of inputs that go into making the U.S. economy. A motor vehicle operating laws, well, that's kind of abstract. The interstate system, physical, non-living, and man-made. Your human heart is a physical, living, natural, and a pacemaker that could keep your heart going in the event that there was an issue is a physical, non-living, maybe, man-made. So let's better understand and just unpack even further the idea of spatial arrangement. Where and how the specific system under focus is located relative to other systems. So where does your system sit in others? So meta is, think about middle. And so as you look at this diagram, you go from meta systems to system. Well, the system next to it is lateral. And then what's under a system? Well, you can break it up into further parts. Systems thinking allows you to think about the holistic system, the entire system, but then you start to unpack it into smaller chunks in order to approach problem solving. So let's think about meta system and the idea of Subway. We all like Subway for the most part, or any kind of eatery, Subway, Chipotle, but let's think about it in this lens. So Subway is fast food. Quiznos is also fast food. Subway has bakers, sandwich associations, ingredients required to make the sandwiches, and an oven. So this is a spatial arrangement of one system under the category of fast food. So let's try to visualize what's going on. We have inputs, transforms, and then outputs. Let's focus on transform. So within the transform portion, it could be, we could visualize a black box, meaning we have no idea what goes on. So for instance, if you think about if you wanted to apply to the Harvard Business School or to Harvard University, you apply, there's a process that happens you have no idea about, and then there's an output. You either get in or you don't. Then let's think about a gray box where there's some knowledge. So for instance, you're at West Point, you know you want to go to airborne school in the summer, and there's some output. Well, if you do well in your military, with your military grades, you're doing well in your company, you let your TAC know you want to go to airborne school, you have an idea that there's an order of merit list that's associated with it, and then the output could be you get accepted to go to airborne school. Or a complete white box. So a complete white box, hey, is this course. You come into this course, you have a syllabus, you have the textbook, You know exactly when things are happening. You know exactly when requirements are due. You know exactly how many points are allocated. So it's actually a complete white box of activity, completely transparent. Let's think about Subway. You make your order, you send your order to Subway, and your food shows up. Same thing with TGI Fridays. Same thing with Uber Eats. If you've engaged in leveraging Uber Eats over the past couple of months, or Grubhub, probably more than normal. And then next, let's think about evolution. So in anything engineering related, there's always an evolution of things. And so the world did not start on the right with the iPhone. There's an evolution that occurred. And there are some who may remember all the way in the bottom left the idea of a Walkman or a cassette player. Cassettes were little squares that had ribbon that you could play, and it wasn't like a DVD where you can pick songs. You had to listen to the whole tape in order to hear a specific song. The next evolution was DVDs. A DVD allowed you to pick songs, but it was pretty big. And then a huge transition was the iPod, where you can now save songs, carry them with you, or then purchase individual songs. And then the combination between 2004 and 2007 of this iPhone apparatus that now has changed how we interact and create a different customer experience. But it was an evolution of technology over time. But with anything, there are always boundaries. And a system's boundary serves to delineate those elements, interactions, and subsystems we believe should be part of a system's definition from those we see as separate. So stakeholders help create boundaries. Stakeholders are those people who care the most about something. Whether you pick an open or closed systems, delineate boundaries, and then what goes in and what comes out could also create boundaries. And so every system has some kind of feedback. You have some inputs, some that happens in the middle, but there's always something going on either inside the system or on the peripheral that may influence what the outputs will be. One way to think about the structure or systems is a discipline known as systems dynamics, which is an approach to understanding the nonlinear behavior of complex systems over time using stocks, flows, internal feedback loops, table functions, and time delays. And so system dynamics allow you to really understand the trade-offs between inputs, outputs, and really focus on the flow. And just a visual representation of a system dynamic model is what we observe here between what are potential adopters versus adopters and innovators. So what are system thinking characteristics? If we've talked about this idea of systems thinking as an idea, well, systems thinkers look at the entire universe, clearly understand boundaries, try to delineate the relationship between things while looking at the ecosystem holistically and trying to unpack the complexity based on those relationships and then communicate across boundaries and come up with a broad range of concepts and principles that allow you to really understand the systems and provide answers to complex problems. And the relationships and complexity are keenly tied together. There are some habits to systems thinkers. There's a whole organization called the Water Foundation that focuses on this idea of what are good habits of systems thinkers. And these are just highlight those different habits. Do you go through a fence or over a fence? How do you understand relationships between different things? And so these are just different ideas around what are habits of good systems thinkers. And so as we go into lesson 2, we've been exposed to system thinking as an idea, understand how we move through understanding boundaries, evolution, spatial arrangements, and some good habits. And we're going to explore that even further through leveraging a case study of OnStar. So let's have a great class today. All systems go.